So if you notice, we're doing lessons 12.3 through 12.5. I'm covering them all because they're basically breaking down, and it's doing each one of these formulas. So we can do them all in one lesson. The hardest part about it is there are more formulas for you to memorize for your test. We'll talk about tomorrow, if you look at them in class, there's patterns, so it's easy to remember them. So what are they used for? Well, if you notice down here, we have our quarter of our unit circle again. And like I told you, that's not going anywhere, and you'll see it again next chapter. We are going to use this. So that'll make 4 chapters in a row where we needed to know this unit circle. Okay, so right here, you would have a question like this. Find the exact value of the sine of 105. Notice exact is nice in bold and in red letters. Alright, so that means you can't take out the calculator and just go sine 105. Mrs. Trulin, where do you want me to round to? Huh? There's no rounding here because that's not an exact number. That's a decimal approximation of an irrational number. You're charged with finding that irrational number. So what we have down here is a list of all the exact values we know. We know the exact value of all of these because all these numbers are represented somewhere on my unit circle. So what I have to do is I have to pick which one of these can get me to 105. So obviously first things first. They want me to do sine, so I'm looking at either doing this formula or this formula. So in other words, can you find 2 angles that add up to 105? And I can only use these angles up here because these are the only ones that I know exact values of. Well, sure. I could go 45 plus 60. That gets me 105. Can I think of 2 angles up here that minus and get me 105? Sure. I can find 2 angles that subtract to get me 105. I could use 150 and 45. That gets me 105. And you know what? It doesn't matter which one you use because both formulas will lead you to the exact value. Alright, so let's try this one over here. Let's try the sine of A plus B. Well, I'm saying I'm going to take the sine of 45 plus 60. Now I have to apply the formula. Sine of adding says I take the sine of the first angle, the cosine of the second angle, and I add on to it the reverse. Now I take the cosine of the first angle and the sine of the second angle. And now I put my unit circle back to work. What is the sine of 45? Here's 45, and the sine is the second value, radical 2 over 2. What is the cosine of 60? Here's 60, and the cosine is radical 3 over 2. Cosine of 45, radical 2 over 2. Sine of 60, 1/2. Now I just have to be pretty decent in Algebra 1 to finish this off. I have to multiply so when I multiply there, I get radical 6 over 4. I have to multiply here. Right, so when I multiply there, I get radical 2 over 4. And then finally I can add, and once again we still have to be strong in our Algebra 1, I can add these together because I have like denominators. So when I add them together, I get radical 6 plus radical 2 over 4. If I take the square root of 6, add to it the square root of 2, take that entire answer and divide by 4, notice what I get, the same decimal approximation. And I'd get the same answer if I did the minus. Now I am going to do the minus, because I'm going to show you what happens. The sine of 150 minus 45. So I take the sine of the first angle, the cosine of the second angle, minus, do the reverse. Cosine of the first angle, sine of the second angle. Sine of 150. Now we have to go back and look at our unit circle and think the sine of 150. All right, the sine of 150 is the same as the sine of 30. So it's radical 3 over 2. And 150 is in the second quadrant, so that's positive. Cosine of 45, great, that's in the first quadrant, no problem there. Radical 2 over 2 minus cosine of 150. Cosine of 150 has a reference angle of 30, so the cosine is 1/2, but 150 is in the second quadrant, and cosine in the second quadrant is negative. If you're forgetting all this, remember it's the all students take calculus. Sine of 45, radical 2 over 2. 45 sine. Radical 6 over 4, look familiar? Negative radical 2 over 4, but since we have two negatives here, turns it into my positive, and voila, I get the same answer. They can give it to you as a proof, which again is not really that hard. I just want to apply my proof, and that means I'm going to take this left-hand side and see if I can boil it down to that right-hand side. So cosine of two angles means that I'm going to use this formula right here. I take the cosine of my first angle, cosine of my second angle, and I minus the sine of my first angle and the sine of my second angle. Now you're looking at me going, I don't know what the cosine of x is. Yeah, but you do know what the cosine of 180 is. If I bring back my lovely unit circle, cosine of 180 is over here, and that's the point -1, 0. So the cosine of 180 is -1 times the cosine of x. What's the sine of 180? The sine of 180 is 0. You see what happens? -1 times cosine is negative cosine x, and 0 times anything cancels out. So I proved. Now these formulas are huge in calculus. You have to know them dead cold. And that's why we're teaching them now to you here in Algebra 2. So that when you get to calculus and you do derivatives and everything, they look familiar. Alright, if you want to run through one more really quick. If I asked you to find the exact value of the cosine of 75. Can any of these numbers down here get me 75? Well, I see right away 30 and 45 can get me 75 if I add them together. So that means I'm going to go to my cosine, and I'm going to take the one where they're adding together. So that problem tells me to take the cosine of the first angle, multiply it by the cosine of the second angle, minus the sine of the first angle, sine of the second angle. We can bring back our unit circle. All right, cosine of 30. Here's 30, cosine is 1/2. Cosine of 45 is radical 2 over 2. Sine of 30, radical 3 over 2. And the sine of 45 is radical 2 over 2. Clean it all up. And that's what you get.